Welcome back, friends. My video where I taught you guys how to count was really popular, so now I'm going to teach you how to code. This is a complete university education. Okay, so variables. Are we serious? Variables are just straight up ones and zeros. Everything you do in the computer is ones and zeros, but variables are especially ones and zero-y. You can change the ones and zeros. You give the ones and zeros a name too. You can name it Peyton. Hi, Peyton. You can't say hi to numbers though. That's weird. You can print them to see what they are. An array is just a bunch of variables in a line. So you can have 1 and 2 and 3 and 4 and 5. You only give it one name though. You give the whole list a name. So if you want x number 2, then it's 3. But that's the third element. Why'd you say x2? That's called zero indexing. We'll get to that later. Okay, so operations. There's a bunch of them. You get adding them and minusing them and timesing them and divisioning them. So here I had Pingus and Gugus, and hoo-ha is just Pingus plus Gugus. But this doesn't do anything. Why doesn't this code do anything? Well, we can print it. Prints things. Now we can see what the code does. I didn't actually run this code because I didn't install GCC onto VS Code, but you know, who cares? Okay, functions. We can put all of the adding and minusing and timesing into a function, like in math class. So you feed functions parameters, and functions poop out return values. Some of them don't though. Those are just called void functions. Those usually just kind of change stuff. But yeah, this will print hoo-ha and bingus together. It'll print the sum. Okay, so loops. So code is pretty much just going in a straight line by now, but now we can loop. So you can do a for loop or a while loop. These just do things over and over. These have parameters too. They're gonna keep looping while the thing is true in the thing. A for loop and a while loop are the same thing. A for loop is just kind of more compact, but honestly, while loops are kind of better. Okay, you can loop with a function too. Please don't do this. This is a good sign that you think you're smart, but you're not. This is called tail recursion. This also does the same thing as the last code, but a lot worse. As a matter of fact, don't use recursion unless you know what you're doing, because you're wasting stack space. Just look that up. I'm not going to explain how you're wasting stack. You're wasting stack and you're wasting time. Just like watching this video. Okay, that's dead ass it. I've just described to you a Turing complete language. You can run Doom on this. You can also simulate the whole universe on just doing this. That's literally it. You could end the video now. But I want to make more money. I want to learn more. I want to work at Google and Amazon. I want to get the guinea. Okay, what's objects? Here, my camera's in the way, but I really wanted to show you guys this. So objects are the spawn of the devil. It's just a pile of functions and variables. I think it's code for businessy people. Like me and my dad, he codes too. Why am I not wearing a shirt? So we make this joke about synergy. Like that's just a word that kind of sucks. We say synergy, and it's just a word that businessy people use that doesn't mean anything. Why don't you just say teamwork, bro? But yeah, so objects make me think of like businessy people who talk like that. And I'm not going to talk about that because I think the video would be boring. But what's a map? Because I said it's like you can make a map. Object's a pile of a bunch of different variables and functions. So what if you just put them together? And then you could have a cool, strange variable that does a bunch of things like a map. What's a map? It turns strings into a puppy. Or a number into a string. Or it turns things into cookies. It does mappings. You give it one thing, it'll give you another thing. So you'd have to put a bunch of functions in, like when I get the string, what do? What if I want to add something to the map? What if I want to remove something from the map? But I just said that I'm not going to be talking about maps because maps are boring, right? Okay. Now, more ways of making money. Multithreading. So if you like to imagine coding, this is what I do. Imagine a little man, a little gnome is reading your code. And the little gnome is doing whatever you tell him to. Imagine with multi-threading, you get two little gnomes, and they can both run your code now, and they can do different things based on their process ID. Well, if you're just doing pure multi-threading, then it's just functions. They're just in different functions, but we're not going to worry about that. I'm going to treat them like they're the same thing. Sue me. But sometimes they'll disagree over things, like what value to set a variable to, and you can tame them with semaphores. I'm not going to tell you what a semaphore is. You can look that up. This is an executive summary of all of university. The internet. Here's the C-socket API. Feel free to figure that out if you want. You just do all that stuff. So then you get, that's how you set up a read and write pipe. What's a read and write pipe? I should probably tell you about operating systems. So what's a kernel? So a kernel is that's the thing at the lowest level that keeps your computer on. When you turn your computer on, it's called the root process. The kernel's a bunch of functions, but the root process is one of them. And when you start Firefox or Minecraft or Roblox, it forks off of this process. That's called multiprocessing. You can ask the kernel to do stuff for you, like read and write to your socket, to the internet. But what's a process? A process is a program when it's on your CPU. That's cool, man. But what's a CPU? I don't know. What's a processor? Processors got registers. Your registers can be pretty big. Usually a lot of them today have 64-bit processors, which it means they have 64-bit pointers, but that really means they just have 64-bit registers. And a register that holds your data and plays with it and then puts it back in memory. It can only play with it in very simple ways, but it does it very fast. But yeah, when a computer says 64-bit, it usually means it's got 64-bit pointers, but it also means you have 64-bit registers, because you can't really point if you don't have the register to point to it. Oh shoot, but what's a pointer? What's the address? So I made the whole way through this video, I'm talking about pointers. So pointers don't actually matter, because all you guys are just going to end up coding in Python and Java anyway, so who cares? So that's the end of the presentation. Go get that job at IBM and Google and DoorDash and Uber Eats. Enjoy the free knowledge I've dropped on you. When you're slinging that money, be sure to thank me.